Hello everyone and welcome back to my channel. In this video we are going to see how in Python we can solve the sieve of Eratosthenes. So for those who do not know what do we understand by the sieve theorem or sieve of Eratosthenes, let us have a quick introduction. Now in mathematics, the sieve of Eratosthenes is an ancient algorithm for finding all prime numbers up to a given limit. It does so by iteratively marking as composite, that is, those numbers who are not prime, the multiples of each prime, starting with the first prime number, that is 2. Now, in order to understand what this particular sieve of Eratosthenes do, let us look at an example. See, what we have with us, we have a certain range of numbers. In the above given table, I have numbers starting from 2. 2 is the smallest prime number that we have, and I have taken numbers till 50, right? These numbers are in the increasing order, right? Now the main sieve theorem is that we have to find out the prime numbers, right? How we are going to do is we will be marking the composite numbers. Composite numbers are those numbers which are not prime, right? So here we have divided numbers into two categories. One is prime and one is composite, right? So what we are going to do is we are going to start from the number that is 2. So you can see that the color of 2 now has been changed so that we can make a mark of it. So we are going to start with 2. Now the next step will be marking each multiple of 2, right? One thing to be noted over here is that the next multiple of 2 in the increasing order is 4, which is also the perfect square of 2. The next multiple will be 6, 8, 10 and so on. So here on your screen you can see that I have marked each and every multiple of 2 with yellow color. But the key point is that the marking will start from the square of 2. The next prime number that we have is 3. You can see the change in the color. Now the next step will be marking each and every multiple of 3. Now this time you can see if I can get the next multiple of 3, which is 6, but 6 is already been marked. Therefore, we will be marking from the next multiple of 3, which is 9. Thing to be noted that 9 is also a square of 3. So the next prime number is 3 and we will be start marking the number from the square of 3, that is from 9. And you can see that I have marked these number with green color, right? So each multiple of 3 is now been colored. That is, all the composite numbers that are actually multiple of 2 and 3 are now been marked. So now moving towards the next prime number, which is nothing but 5, right? Now talking about 5, the multiple of 5, that is 10, it has been already marked. The next multiple is 15, which is also in turn a multiple of 3 is already been marked. 20 is also marked, but the next multiple of 5 which is not marked is nothing but 25, right? So starting with 25, then we will be coloring each and every number which is the multiple of 5. So 25 is already been marked, then 30 is marked because of 3, then the next multiple is 35, this will be marked because of 5, then 40 already marked, then 45 already marked, and then 50. Now the next prime number will be 7, right? So starting with the multiple of 7. Now 14 must be marked, then 21 is marked, then 28 is already marked, then the next multiple, all the multiples are actually been marked over here, but the value that we need to mark over here will be the square of 7, that is 49. Now coming on the next prime numbers, they are out of the range of 50. So that is because the name is Sieve of Eratosthenes, because it is going to filter out each and every composite number, that is the non-prime numbers, through this particular method, right? So the next thing that we are going to do is we will be programming this Sieve of Eratosthenes in Python. So let us see how we are going to do that. So here I will be making a function with the def keyword and will name it as prime sieve. right? And in this particular function, what I'm going to pass is a range. And as a parameter, I'm going to take a number, say n, which is going to represent that I want to print prime numbers in the given range 50 or 100 or so on, right? So in the example, I have taken 50, right? So colon and now the body of your function. In this, I'm going to represent the numbers, that is in the example table I have taken from numbers from 2 to 50 in a list, right? So let me name my list as prime, and here I will be making use of list comprehension. I want a list with all the numbers in it as zeros, right? Why I have taken this as zeros? Because initially no number has been processed and I do not know whether the number is a prime number or the number is a composite number, right? So Sieve in the initial state do not know what numbers it need to filter out, right? So each and every number before processing is 0. So here I will be making list comprehension in which all the elements of my list will be 0 in the initial state, right? So range, and for instance here let me take range of 100 numbers. So I have a list of 100 numbers, right, which are each element of it is 0, right? Now next, in order to filter out the numbers, right? Initially, we do not know what to filter out and what to keep, right? But now in order to filter out the number, I need certain logic, right? So what that logic will be, I will be making use of a for loop for I in range. Remember, the table starts from 2 because 2 is the smallest prime number. So from 2 to n plus 1. Let the value of n be 50 in our example, right? So I want to include 50 also. So n plus 1 starting from 2. Now, what I want to do is, if the numbers are not processed, right? If the first number is not processed, remember the range is starting from 2, right? So this is representing numbers from 2 to 50, right? So if the element in my list, that is prime I, which is 0, right, is equal to 0, right? What we need to do is we are going to mark it. Let us make another for loop. We are going to mark it as non-prime, right? So what we are going to do, for 2, the first multiple starts from 4, which is the square of 2. So when I is equals to 2, so I will be taking square of 2, the number will going from this, and I will be skipping from I because I need multiples of I, right? So I will be 2 plus 2 4, right? 4 plus 2 6, 6 plus 2 8. So skipping each time by I for 2, right? When the number will be 3, then we will be skipping by 3 because that is how the table works, right? Adding the numbers, right? So colon and enter, and prime j is equal to 1. So if the number is processed, then the number is 1, else the number is 0. Now remember one thing over here. 1 will be the numbers which are composite, right? Because if it is multiple of 2, then the next number will be 4, then the next number will be 6, then 8. We have to skip those numbers. That means the sieve need to filter them out, right? So if the value becomes 1 in my prime list, then we have to leave that number. And if the number is still 0, that means that is our prime number, right? So we have two datas over here. The one data is in your prime list which is 0 or 1, which is indicating that if the number is 0, that is indicating that it is prime. And how we are keeping track of those particular numbers? With the help of this for loop, right? So if 1, then the number is composite. So we need to skip out that particular thing. Now, what we need to do is now to print the values of my prime number. So for I in range, the range will again start from 2 only, because 2 we need to keep because that is also a prime number, will go up till n plus 1. And now if prime I is equal to 0, that means I'm talking about prime number, that is the leftover prime numbers, right? The leftover prime numbers. And at that point of time, I need to print the value of I, and I want them to get printed in a same line, right? So that is the function which will going to print the all prime numbers. Now in order to run this particular code, I need a value, let's say range, and I need a number, so that should be an integer. Input, enter a number till which we want to print the primes, right? So I want to print primes till 50, so I will be entering 50 over here, and I will be calling prime sieve, my function, on this variable, right? So now if I run this code, then on your screen you should get each and every prime number printed. One more thing, I think there is one error. This should be one single equal to sign. Now let me just run the code and enter the range of prime numbers. So I want first 50 prime numbers, and yes, on your screen you can see that all the prime numbers has been now printed, right? Let us also run this for some greater values. So if I run it again, and if I say that I want first 70 ranged prime numbers, so yes, it's working very fine, right? So that was a small description of how we can code the sieve of Eratosthenes in Python. So I hope that this particular example was clear to you, and if you like the explanation, then do subscribe to my channel and don't forget to share the video. Thank you.